Hey guys, welcome back to another one of my videos. So here we'll be going through a complete walkthrough for the Jan 2019 paper 2HR of the new spec 4MA1. And as always, we're going to go through everything step by step and see how it goes. But yeah, let's jump in straight to number one. So the table below gives information about the number of days that 100 cars, i.e. all the total frequency, were in an airport car park. So for example, if we look at the first row, it says that between 0 and 4 days, there were a total of 16 cars. And on the second time, between 4 and 8 days, there were 18 cars, and so forth. Now A, write down the modal class. So modal essentially means find the mode, or the most common number of days where they had the highest frequency. So all we do is look at the one that has the highest frequency, which is 27, and that is represented by 12 to 16 days. And that's your answer. So you write the class here. 12 less than D less than equal 6D. Okay, part B. Work out an estimate for the mean number of days. Okay, so to calculate the mean, we just need two things, and we always need this. First, we always need the midpoint, and that's literally the midpoint of days. And next, we need something known as fx, where f is the frequency and x is the midpoint. Now, the midpoint refers to the value between the interval. So in other words, between 0 and 4 days, we know the midpoint is 2. Between 4 and 8 days is 6, and so forth. Then you're going to get 10, 14, and 18. By the way, if you're not too sure how to calculate a midpoint, a nice method is to actually sum them up. For example, to get a midpoint of 6, we can say 4 plus 8, which is 12, and then half of it, you get 6. Or 8 plus 12 is 20, half of it is 10. And yeah, this is helpful if the values are very complicated. Now to get fx, just multiply across, yeah? So 16 times 2 is 32, and then so on, 18 times 6, which will give us 108. Next one is 190. 27 times 14 is 378. And lastly, 20 times 18, 360. And now all you want to do is total these up. And when you total them up, you should get 1068. All you do now is use the total fx, so the mean equals total fx, which is 1068, over total frequency, which is 100. And doing so will give us a mean number of days of 10.68. And that's it, guys. That's one done. Okay, number two. So the diagram shows two solid toy bricks, A and B. Okay, A is a triangular prism of length 5. The cross section of A is an isosceles right angle triangle. Okay, so that means you got equal size on both, which is of 6. Brick B is half a cylinder of length 5. That's cool as well. You can use the volume of a cylinder formula. The semicircular cross section of brick B has diameter of 6. Okay, now the volume of brick A is greater than the volume of brick B. How much greater? The answer to 1 dp. Alright, so essentially just got to find the volume of both and then find the difference. So let's find the volume of this first shape here. Now, to work out a volume of any given prism, the best way to do this is to work out the area of its face, the cross-section area. So 6 by 6 over 2. That's the area of a triangle, 6 by 6 over 2. And then multiply across by 5 by its additional length. And we can put that in the calculator in a second. Now, to work out the volume of this half cylinder, first things first, we write down the volume of a cylinder, which is literally pi r squared times the height, and then because it's half a cylinder, you just divide it by 2 and you're done. Now all you want to do is just substitute the values in and we've got it. So basically the solution of the first one is going to give us a total volume of 90. So this is 90. Now for the second shape, if you work out the volume of this one, we know that the radius is actually this bit here. It's half the length of the diameter. So 6 is diameter, by the way. So cutting this and just drawing a line across, this would be a radius of 3. And the height of the cylinder is 5. So it's going to be pi times 3 squared times 5 all over 2. And if you put this in the calculator, you're going to get 45 over 2 pi. And that's it. Now we just subtract both of them to see which is bigger. So in your calculator, write 90 minus 45 over 2 pi. And you should get an answer to 1 dp of 19.3 centimeters cubed. And that's it. Okay, number 3. So here are the first 5 terms of a number sequence, yeah? Find an expression in terms of n for the nth term. Okay, so before we even do this, we look at the sequence and we ask ourselves what's happening. Well, it looks to me like they're going up in plus 6s. And now for part A, when they want you to find the nth term, a nice little trick is to literally ask yourself again, what is it going up in? Well, it's going up in 6s, so it'll be 6n. And then we just circle 10 and just go 1 back. If we subtract this by 6, we get plus 4. And that's it, guys. That's literally my way of finding the nth term. Alright, part B. So the nth term of a sequence t is given by n squared minus 3. Okay? There are numbers that are terms in both sequences s and t. Find one of these numbers. Okay, what this is actually telling us is that both of these sequences must have the same term. Now, if they have the same term, there's a good chance that at some value of n, these two equations will be equal. So we say, alright, this is telling us that n squared minus 3 must equal 6n plus 4 at some common n value. And that's it. Now, to literally evaluate this, let's go ahead and move all these terms to the left side, yeah? So subtracting 6n and subtracting 4, you're going to get n squared minus 6n minus 7 equals 0. So now, in order to solve this so simply and easily, we could just use a quadratic formula, where a is 1 is the first term, b is minus 6, and c is minus 7. So the terms in front of the values, yeah? So using the quadratic formula, it looks a bit like that. It's minus b plus minus the square root of b squared minus 4ac over 2a. Now, by the way, guys, some of your calculus can already solve this. So if you can just put in your calculator the quadratic formula, you can just skip this part. For everybody else that wants to use a formula, let's keep going, yeah? So for this bit now, replacing minus b, since b is minus 6, minus b will become plus 6. That'll be plus minus the square root of b squared, which is minus 6 squared, minus 4 times a times minus c, all over 2 times a. And again, putting this all in your calculator, but first using the plus sign, we're going to get a result of, let's see, 7. And if you use the minus sign, you can get a result of negative 1. So now we have to choose which of these two values do we keep. Well, for the nth term only cares about your position, so the first or second or third. We can't have a negative position, so the only answer is 7. So the value of n must be 7. And by the way, the answer is not done yet. So now we plug in n equals 7 to any of these nth term equations. So I'm just going to plug into this one because I can see it. And when you plug in, you're going to get 7 squared minus 3, which will give us 46. So this is one of the terms they're talking about. Okay. Yeah, and that's it, guys. I think we're done. Okay, number 4. So on Saturday, Jacob walked 10,800 steps. Now the next day, he walked 7% more steps than on Saturday. Work out how many steps Jacob walked on Sunday. Okay, nice and easy. So here we can just literally use the OV formula. So OV times 1 plus or minus a rate will give us a new value. Now for this kind of formula, you could always use it for any percentage based questions or compound interest questions. So here we can say that the original value he walked was 10,800 steps, and his rate of increase was 7%. So it's going to be 1 plus 7. And this will give us a new value, which is in a calculator, 11,556 steps. And that's how much he walked. Alright, number 5. So the scale drawing shows the position of a hall and the position of a library. And here they are. Now the scale tells us that 1 centimeter on paper, it represents 20 meters in real life. Now the post box is 140 meters, in other words, 7 centimeters if you divide by 20, from the library on a bearing of 220 degrees. So you have to travel 220 degrees and you go straight down around here. Show the position of the post box on the scale drawing. Mark the position of a cross and label it P. Okay, so this kind of question is unique in the sense that I'm not going to be doing it on paper. Everything's going to be done on screen, okay? So I've already actually solved the problem. I'm just going to show you guys how I did it and the tools I use. So the first thing you want to do here is realize that you're dealing with a bearing of 220 degrees. What that means is that you start from the north line and you do like a full, like a 220 degrees circle clockwise. You'll notice that you're going to cross 180 degrees and your protractor only goes up to 180. So what I would personally recommend is do something like this. Firstly, draw a straight dot line down and just angle it at 180 degrees, and realize you need to find an additional 40 degrees here from this point here. And to do that, and here's my protractor, I put a marking over here. Yeah, so you can see the 40 degrees here. And now you just want to draw a straight line all the way across using your ruler that makes exactly 7 centimeters down, and a mark at the bottom, a P, like over here. And yeah, and when you do that, you've done it. So now let's do part B. Oh yeah, don't forget to put an X as well, yeah, to mark the spot. So use your scale drawing to find now the real distance in meters of the hole from the post box. So P is the post box. Now you're just going to draw a straight line over here. And when you do that, you're going to get a distance of roughly 7.7 centimeters. And that's equivalent to 154 meters if you times it by 20 using the scale representation. Okay, so that part's okay. So again, this part here was point P, and we traveled all the way across it using a ruler, yeah? So that's the length of the line. Now finally, they want us to calculate the bearing of the hole from the post box. So now we draw a north line at the post box. So it's going to look like this. And then you're going to do a clockwise movement around this over here. Now the smart thing to do is, instead of doing a clockwise, just work out the angle difference between here and here. So to do that, put your mark in here. And you realize that you're going to get, it says 150 here, but the actual real difference between 180 and 150 is 30 degrees. So there's a gap here of 30 degrees, meaning if we went all the way around, it'll be 330 degrees clockwise with a bearing. Okay, number 6. Okay, so pentagon ABCDE is shown inside a regular octagon. Okay, so here's our pentagon and here's our regular octagon. The pentagon has exactly one line of symmetry, so I'm guessing it's split in the middle like this, yeah? So this is our symmetry. Now this, because of that symmetry, this pretty much implies that this angle and this angle must be the same. So let's just call them both y. Okay, so now we got this, and before we even answer the question, let's try and figure out what y is, yeah? And this would help us find x, which is what they want. Now to find y, we need to first ask ourselves is how much does a pentagon add up to, at least all its angles. Now a nice method we use is the sum of interior angles, so the sum of all the angles inside. And the general formula is always the number size minus 2 times 180 degrees. Okay? And now because we're dealing with a pentagon here, it's a 5-sided shape, so it'll be 5 minus 2, which is 3. 3 times 180. If you put this in a calculator, you get 540 degrees. Okay, so now we know that all 5 of these must add up to make 540. So we can say that 112 plus another 112 plus 84, which is 308 degrees, plus these two angles y, so plus 2y, must make 540. And now we just go ahead and solve this. So making y the subject, we can subtract 308 across. So it's going to give us 232, so 2y equals 232 degrees. And then we just half this to get y. Now halving this value, you're going to get 116 degrees. Okay, so now we can update this. Okay, so now we know that y is 116. We can go ahead and deal with this regular octagon, yeah? So one key thing to note, because the shape is regular, this means that all of its angles and lengths are the same. Okay, that's literally the number one tip. All of them are the same. Now let's use the same method and figure out how many angles the regular octagon is supposed to add up to, yeah? So we can say that the sum of the interior for a regular octagon, which is n minus 2 times 180, where n is the number size, so we have 8-sided shape. So 8 take away 2 is 6, so 6 times 180 is 1080. And now we can say that each interior angle, by the way, so to get each angle, if we know all of it adds up to 1080, we can divide it by 8 to get each angle. So 1080 divided by 8 is 135 degrees. Okay, so this means here, this is 135, this is 135, and this means these two combined is 135. So therefore we have 116 plus x must give us 135 degrees. So therefore, just solving for x by minusing 116 across, we're going to get exactly 19 degrees. And that's it, guys. Question solved. So the diagram shows us a trapezium, and they want us to work out the value of y, which is this length over here. Okay, so this one is not as obvious, but what I personally recommend, when you get shapes like this and you got angles and lengths mixed up, what I would personally do is go ahead and try and split this up into compound shapes, yeah? So you see this rectangle here and this kind of triangle. If we draw like a little dotted line here, we're going to get a nice right angle triangle. And we know that this length here, which is parallel to that 15, must also make it a 15 centimeter length, yeah? And we can call this little extra length x, yeah? So let's just ignore y for a second. Yeah? Y is going to be like the whole thing. The whole thing is y. Now, if we just pull out this right angle triangle for a second, yeah? And we're going to go ahead and try and work out what that x is. Because if you work out x, you can work out the whole thing. Okay, so you got 15 and you got, what is it? we know that the whole angle here is 125. If we split this up, we have a right angle triangle, so this is 90. This means the leftover bit here from 125 90 must be 35 degrees. And that's what we're going to put over here. Okay. Now, to solve this one, this is a straight up SOHCAHTOA problem, yeah? So SOHCAHTOA, so it's a trig problem. And now, when you do a trig problem, we always care about two things, yeah? We care about the relevant side and the fact it's right angle. So looking at this here, we can say that the length opposite angle is the op, so the O, and the one next to it is the adjacent A. And that's what we care about. Always avoid trying to label every side, just label the relevant sides, yeah? So because we got O and A, we can say now that that involves TOA, because TOA has O and A, and CA and SO don't. So this means, using the formula, we can say we have tan of the angle, so tan 35 must equal the opposite, x, over adjacent 15. And now all you want to do, guys, here is rearrange to make x the subject. So timesing 15 across, we're going to have 15 times tan 35 equals x. And that's it. Now if you just enter that in your calculator for a second, you're going to get an exact length of about 10.5. Now I guess we're done. So since we know that this little length must be 10.5, and of course this whole thing is 37, which means this length is the same, which is also 37, we know that the total length y must be 37 plus 10.5. And when you do that, you get a total length of 47.5 centimeters. And that's it. Simplify fully this fraction here. Okay, these questions are nice and simple, thankfully. Now, the trick is to simply look up and down and cancel common terms. So let's take it step by step, yeah? So let's work with 15 over 5. 15 divided by 5 is just 3, so put 3 here. K to the power 4 over k. So when you're dividing terms, you subtract the powers. So think of k as having a power of 1, yeah, because it's 1k. And 4 take away 1 is 3. So we're left with k to the power of 3. And then you do the same for the next one. M to the power 3 take over m to the power 2. You divide and so subtract the powers. 3 take away 2 is 1. So you're left with m to the power of 1. And you can just write that as 3k cubed m. And we can leave it like that. Now B. Solve the inequality. Alright, so for this kind of problem, just imagine these are two equal signs, yeah? And you just and the objective is to get x between two things, alright? And to do that, we need to firstly deal with this minus 1 and then deal with the 4. To do that, we can firstly add 1 across, so we're going to have 8 on this side, and add 1 here, you can get 18. And lastly, we need to divide by 4. So dividing by 4, you can get 8 over 4, which is 2. And 18 over 4, well, put that in your calculator, you're going to get 4.5. You could leave it as a fraction, no problem, but it's always good for inequalities to leave it like this. Okay, and that's it. Okay, number 9. So Omar invests 6,000 dirham for 4 years in a savings account. He will get 1.5% per year compound interest. Okay, so this alone tells us we need to use the OV formula, which is OV times 1 plus or minus a rate will give us a new value. And now because we're dealing with multiple periods like 4 years, we put a power 4 here. Okay, work out the total amount of interest Omar will receive by end of 4 years. Give your answer correct to nearest dirham. Okay, before we work out the second bit, let's go ahead and update these values, what we know, yeah? We know that the original value is 6,000. We're going to increase it, so we use a plus value of 1.5%. So ignore the negative because you're not decreasing. And we charge out by power 4. And then when you do this, you get the answer. So put this in your calculator and you'll get exactly, roughly 6,358.18 to 2 decimal places, yeah? And now finally, this, and by the way guys, this is the money you get after 4 years, yeah? Now the question here wants us specifically to work out the total amount of interest Omar will get. Now the interest is literally the money, the extra money added on from the original amount. And if you look at the two values, you can see that 6,000 has gone all the way up to this amount. So go ahead and do your answer you just got right now, minus this by 6,000, and then you'll be left with the interest component. And if you do that, you're just going to get exactly 368.18 dirham. And that's it. And now the question wants us to give your answer correct to the nearest dirham. So in other words, the nearest whole number. So your answer is just basically 368 dirhams. And we're done. Okay, number 10. So simplify fully this expression here. Okay, these questions are super easy if you know a trick. Now, every time you deal with powers and there's no plus or minus signs, literally distribute the power to every single term. So the 16, for instance, will get 16 to the power of a half. The x, which already has a power, will get an additional half. And the y, which already has a power, will get additional half as well. And now we just tidy this up. So 16 to the power of half, you can just put that in the calculator literally, and it'll give you the answer of 4. Now for the second bit, you got 8 times a half. So when the powers are on the same level, you just multiply, yeah? So 8 times a half is 4, so it'll be x to the power of 4. And same thing here, y, and then 6 times a half is 3, so y to the power of 3. And we're done. Now for B, they want us to solve this fraction problem here. Show clear algebraic working. Alright, for every single algebraic problem, guys, yeah, and this is general, you would always want to clear the fraction, because fractions does not make it easier. Now notice how you got 3 and 2 here. Now what I would personally do is multiply the common denominator of both, yeah? So if we got 3 and 2, we can say 3 times 2 is 6. So we're going to multiply the whole equation by 6. And before you do that, guys, always wrap a bracket around these, because I'm going to show you why in a second, yeah? When you times everything by 6, we're going to have 6 times 8 minus 2x over 3 minus 6 times 2x minus 3 over 2 equals 4 times 6, which is 24. Now we can go ahead and simplify some expressions, yeah? Notice how you got 6 over 3. These two cancel out and you'll be left over 2. And you got 6 divided by 2 will be left over 3. So we literally have 2 times the bracket, 2 times 8 minus 2x, and 3 times 2x minus 3. So let's do this, yeah? Expanding the bracket now, we got 2 times 8, which is 16, minus 2 times 2x is 4x. For the next bit, we're going to have a minus 3 times 2x, which is minus 6x. Next one, we're going to have minus 3 times minus 3, which is plus 9. And all of this is equal to 24. And yeah, now here's the easy part. Now all you want to do is collect like terms, yeah? So you got 16 plus 9 is 25. Minus 4x minus 6x is minus 10x, all equal to 24. Now let's go ahead and move 10x to the minus 10x to the right, so it becomes a plus 10x. And we're going to move minus 24 to the left, so it becomes minus 24. So subtracting 24, you get 1. Adding 10x, you get 10x. And finally, to get x, divide this by 10, and you're going to get 1 over 10, or 0.1. And that's it. And now finally, for part C, they want us to make f the subject of here. Now these are literally my favorite kind of questions. And to do this very easily and quickly, you see you got square root here. Let's get rid of that square root. So the opposite of square rooting is squaring. So if you do that, you're going to get m squared, and that vanishes. Oh, and one more thing, yeah? You got 1/3 times EF. You can just stick this together. 1 times EF is EF over 3. And by the way, this is also recommended, yeah? Now next step is to, what we're trying to make f here. Next step is to clear the fraction, so times 3 across. You get 3m squared equals EF. And now you want to separate these two guys. So to separate E from F, divide it. So you can get 3m squared over E equals F. Okay, number 11. So we got two straight lines. One has this equation, another one goes through 2 points. Now Michael says that both these lines are perpendicular. Okay, so we're going to question what that is in a second. Is Michael correct? Alright, so first things first here, before we even answer this question, let's go ahead and try and make two equations, yeah? The first thing is to always rearrange these equations or create an equation in this format, which is y equals mx plus c, where m is the gradient and c is a constant. Now, if we look at line L1 for a second, we can kind of see that they've almost done it, but they got in the wrong form. So all we have to do is just rearrange and make y the subject, yeah? So let's just work with line L1 for a second. So if we subtract x across, we're going to have 2y equals, and I'm going to put x first here, minus x plus 4. And then I'm going to half this. So we can get y equals, instead of writing minus x over 2, I'm going to write minus half x. And half of 4 is 2. So over here, we can see that we have a gradient for this line of m equals negative half. Now, one thing to note, yeah? When they say two lines are perpendicular, perpendicular means that both lines are at a 90-degree angle from each other. And to prove something's perpendicular, the gradients need to be a negative reciprocal of each other. In other words, we need to either show that he's wrong that the gradient of the second line will be the negative reciprocal of this first gradient. Now reciprocal means you flip upside down, so it'll be 2 over 1. And negative reciprocal means you flip the sign to make it positive. So the gradient of the second line must be a plus 2. If we get plus 2, then he's correct. If we don't, then he's incorrect. Okay, so that's the target, yeah? We need to see if we get this one. Now for line L2, let's work with it. To get the gradient of a line, there's literally a beautiful formula. The gradient is literally the change in y over the change in x coordinates. Now the change in y, we look at both y's. We've got minus 7 and 9. So we subtract them. It'll be minus 7 take away 9 over the change in x, which is minus 1 and 7. So minus 1 take away 7. And doing so, and just to see what you guys get, you should get, oh, you get exactly 2. So yeah, so therefore, because the gradients are inversely, what was it again? Is an inverse reciprocal, therefore they are perpendicular. So okay, number 12. So Freddie recorded the number of runs he scored in each of the 11 cricket matches, and these are the results. Now they want us to find the interquartile range of his results. Okay, so every time you have a list of data like this, which is not organized, always rewrite it in numerical order from smallest to the biggest value, yeah? This is going to help you calculate either the median, the quartiles, or even this one. So let's go ahead and do that first, yeah? So start with the smallest value, we just tick and cross. We have a 0. Next smallest is a 4. And then we have a 6. And you just keep on doing this, yeah? 9, 9, and 102. Okay, and just count the values, yeah? You should have 11 pieces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so now to find the interquartile range, we do it like this. Let's go ahead and find the median first, yeah? Just split this up equally. If you've got 11 pieces of data, the middle should be around here, around 21, where you got 5 on this side and 5 numbers on that side. The first quarter would be here, where you got 2 here and 2 here. The third quarter would be on this side, so you got 2 here and 2 here. So all the numbers have to be equally distributed. Now the interquartile range will be the difference between the third quarter, which is 51, and the low quarter, which is 6. So it's 51 minus 6, and that's going to give us 45. So the interquartile range of his results had a difference of 45. Okay, number 13. Carlos, Flavia, and Tazia shared 861 pounds between themselves. Okay, so let's go ahead and start writing equations for this, yeah? So we can say that C plus Flavia plus Tazia shared 861 pounds, okay? So that's how much they had altogether. Now, the amount of money Flavia got is 65% of the amount of money Carlos got. So we can say that Flavia had exactly 65% of Carlos's amount, okay? Next step, the amount of money Tazia got is 22% more than the amount of money Carlos got. So to literally summarize that short, Tazia had the same amount as Carlos plus an additional 22% extra of Carlos's amount. Now, work out how much money Carlos actually got. So this is a case of, and the beautiful thing about this question is this is a case of literally substituting all these letters F and T with everything in terms of C. And then you can just solve to find what Carlos got. But before we do that, let's go ahead and simplify every step here. So for the first one, 65% of C. 65% in the calculator is 0.65. And off is time, so it'll be 0.65 times C is 0.65 C. Now for Tazia, C plus 22% of C. So 22% is 0.22. This is like 1C. So 1C plus 0.22 C is 1.22 C. And that's the second variable. Now all you guys want to do is substitute both of these into here and here. Okay, so you can get something like C plus, instead of F, it'll be 0.65 C. Instead of T, it'll be 1.22 C. And it's going to equal 861 pounds. And now we just solve to find C. So collecting your like terms, your C terms, is 1 plus 0.65 plus 1.22. If you put this in the calculator, you're going to get 2.87 C's equals 861. Now, just literally divide that across. So you have 861 over your answer. You're going to get C equals exactly 300 pounds. And that's how much Carlos had, 300 pounds. Since you know the value of Carlos, you can also find the value of Tazia's amount and also Flavia's amount. But they just want C. So given that A equals 3 to the power X and B equals 3 to the power Y, expressed in terms of A or B or A and B, each of these ones. Now the logic behind this is to literally rewrite all these terms into exactly what they want and then attach powers or other things. So for the first one, 3 to the power 2x. Since we only have 3 to the power x, we can kind of factorize the 2 out, so it would be something like 3 to the power x all squared. And now we know what 3 to the power x is. 3 to the power x is a, so it's going to be a squared. Okay. For the next part, 3 to the power x plus 4y. In this case, when you're adding powers, you can actually partition it into something like the product of powers. So 3 to the power x times 3 to the power 4 power y. And now we know what 3 to the power x is, but 3 to the power 4y is not what they want for b. So what you could do is literally replace 3 to the power x with a, and just like the first term, we found out that 3 to the power 2x is a squared, so 3 to the power 4y must be b to the power 4. So a times b to the power 4. Okay, so that's done. Now for the last bit, same thing, yeah? So we're going to partition this again. So this would be 3 to the power y times 3 to the power minus 1. Well, 3 to the power y is easy. It's just going to be b. And 3 to the negative 1 is a third. So it'll be a third of b, which is b over 3. Done. Now, next bit, okay, so they bring the same info back. They tell us now that a times b gives us 2187, and a squared b gives us another result. Work out the value of x and the value of y. Show you're working clearly. Okay, so this looks like we're going to do some sort of simultaneous equations, yeah? By the way, a little quick tip here, yeah? What you could do is firstly, and solve this super easily, is to try and work out what the value of a and b is first, before we work out the value of x and y, yeah? So to do this, since we know that a times b is this value here, this one is a squared b, which is the same as a times b equals that amount right here. So what you could do is just replace this ab with this result here. So you're going to have a times 2187, which is 2187a equals the right hand side. And then you could just divide it across to solve for a. And when you do that, you should get exactly 81. So the value of a is 81. And now, because you know what a is, you can go ahead and make b the subject from the first equation. Since because you've got ab equals 2187, therefore b equals 2187 divided by a, which is 81. So it'll be 2187 divided by a, and you should get also 27. Okay, so that's the value a and b found. Now you got a and b, we can literally plug it into the first equation, yeah? So we know that a to the power, a equals 3 to the power x, b equals 3 to the power y. So therefore 81 equals 3 to the power x, 3 to the power of y. Now there's literally a beautiful method. Sometimes we're not too comfortable with powers, guys, yeah, and I totally get that. What we could do is use something known as logs. If you had a general equation, suppose it was like 81 equals 3x. You would just divide 3 across, isn't it, to get x, which will be 81 over 3. In this case, because they're in terms of powers, we need to use a special button on our calculator known as the logs, or the ln's, yeah, the natural logs. So yeah, to solve this nicely, we're going to use the log function, yeah. So we can say therefore x must equal, if you divide 3 across, log 81 over log 3. Okay, and if you put this in a calculator, you're going to get exactly 4. Likewise, if you did it for y, you can get y equals log 27 over log 3. And by the way, guys, this is actually an A-level technique, yeah? So you're not really supposed to know this, but if you use it, you won't get penalized. So x is going to be 4 and y is going to be 3. And that's it, guys. Problem solved. Alright, number 15. So Barney has a biased coin. Okay, so it's not fair. So all probabilities will be different here. When the coin is thrown once, the probability that will land on heads will be 0.3. So this means tails will be the other round, 0.7. Because all probabilities must always add up to 1. Now, Barney throws the coins 4 times. Work out the probability that the coin will land heads exactly 3 times. Okay, so for these kind of questions, it doesn't tell you the particular order how they should do it, as long as you get exactly 3 heads. So we ask ourselves, what combinations can we get? Well, you can get heads 3 times in a row, and the 4th one must be tails, or you can get heads twice in a row, and then tails, and then heads. And you'll probably realize that you can arrange this in 4 different ways, yeah? So something like that. When this happens, you're going to get the same probabilities each time. So you can literally just rewrite this as 4 times the probability of getting 3 heads and a tails. This will give you the same result, guys. Now, to actually solve this probability, to get probability heads, we know is 0.3. To get another head, 0.3, and then 0.3, and then a tails, 0.7. If you put all this in your calculator, and of course times it by 4, because there's 4 outcomes of it, 4 different ways, you're going to get exactly 0.0756. Okay, so this will be your answer for A. Work out the probability that the coin will land heads at least once. Ooh. So this one's actually a clever way of asking it. What they means is that the probability of getting head once, so you need to get 1 heads and 3 tails, or you can get 2 heads and 2 tails, or 3 heads, 1 tail, and lastly, or 4 heads. Now, as nice and simple as this all looks, the only problem is that you're going to have to work out the several different combinations as well, which is good. It's just going to be time consuming. However, you'll probably realize that there's actually a single combination which we never looked at, which is tails, tails, tails. And this is literally the only combination you cannot get. So why don't we just do this? Why don't we just find the reverse, the probability of not getting heads at all? So probability of getting just straight tails. If you work this out, you realize that you could just 1 minus that probability of getting straight tails, and it's going to equal the same result as all of these guys. That's the cool thing. And yeah, if you do that, you're going to get 1 minus 0.7 times 0.7 all the way across 4 times. And this is going to give us a final answer of, according to my calculation, 0.7599. And that's it. So 120 people who visited a sports center were asked if they went swimming, played basketball, or used the gym. Alright. Now, according to this, the answers show the following. So we've got like literally various combinations, yeah? Using this information, complete the Venn diagram below to show the number of people in each region of the Venn. Now, with this kind of question, yeah, and this is literally how we should always do it. You always try and always work out the inside first before you go to the outside. So work out all the combinations that they all did together, and then 2 of them doing 2 of the things together, and then individual elements. And then we work out and see if we get the correct numbers. So let's start with the inside, yeah? And usually you always start at the bottom. So it tells us that 2 people went swimming, played basketball, used the gym. So we're going to put a nice little 2 there. So that's 2 people. Now the 3 before it. It says that 7 people went swimming and used the gym. So 7 people went swimming and used the gym. So this area here must equal 7, including the 2. So this has to therefore be 5, because 5 plus 2 is 7. Now the next bit says that 5 people played basketball and used the gym. So B and G. So 5 people did this area, meaning you had a difference of 3 that did just basketball and gym. And lastly, 3 people went swimming and played basketball. So again, 2 plus 1 will give us 3. Now we pick the individual elements. So 27 people use the gym. So this entire G circle must equal 27. So let's add this up. So you got 5 plus 2 plus 3, which is 10. And you've got 17 left over, making 27. According to basketball, 16 played basketball. We've got 1 plus 2 plus 3, which is 6. Take that away from 16, you got 10 remainder. And lastly, for swimming, you got 28. So 1 plus 2 plus 5 is 8. 8 take, oh, I love the numbers. 8 take away 28. 8 from 28 is 20. Okay, so now you got all the numbers. We need to firstly check if all of this adds up to 120 people, yeah? Now, just look at the numbers. It doesn't look like even close to 120. But if you actually added up every single value here, you'll realize that there were altogether 58 included in these 3 sports. Now, this is nowhere near 120. So this means that out of these 120 students, if you subtract them from 58, 62 were doing different things. And that's it. That's literally all you have to do. Now, finally, for part B, it says one of the people who went swimming, i.e. one of the people, so we're talking about a collection of just this group here only now, is chosen at random. Find the probability that this person out of the swimming group also played basketball. So let's have a look. How many people played basketball in that swimming group? Well, you got here and here. So you got a total of 3. So you got a total of 3 students out of that swimming group, which is 28. And that's your probability, guys. This is literally done. Okay, number 17. So we got P equals EF, where both E and F have been rounded to 2 significant figures. They want us to find the lower bound value of P. So in other words, the lower bound value of EF together. Now to do this, and before we even look at it, we need to firstly work out what the upper and lower bounds are for E and F. So on the right hand side, let's put E and F here for a second here and put some bounds. So it's always less than equal to the left and just less than on the right. Why? It's because when you're rounding from an upper value, it can't be a certain number. It has to be just below that. Whereas for a lower bound value, it can also equal it. And you'll see. So to work out the upper bounds, it's always easy. Just copy these numbers out on the right side. That's my trick. So copy this down and then just add a 5 across. To find the lower bound value, you'll realize that the difference between 4.85 and 4.8 is going to be 0.05. So just subtract this number from this 4.8 to get the lower bound, which is 4.75. Again, the difference between 0.265 and 0.26 is also 0.005. Minusing that across from the original value, you can get 0.255. Another way to see this trick is to just realize that this unit value goes down by 1, and then this unit value goes down by 1, and that's it. Now, let's try and solve the question. So to get the lower bound value of P, we need to ask ourselves, how do we multiply E and F to make it so tiny? Well, the trick is to get the smallest possible value of E and multiply against the smallest possible value F. So in other words, the minimum value of E times the minimum value of F, which is these two values. And when you do that, you're going to get exactly, so just write it step by step, 4.75 times 0.255. You're going to get exactly, to three standard figures, 1.21. And that's it. That's A done. Now for B, it's the same thing, but now you got division. So again, but then now it's been rounded slightly to different number of places. But here they want to work out the upper bound for the value of Q. So once again, let's put T and W on the side. Put some bounds here, so less than equal, and just less than here. And now, once again, copy these digits out. So T is 2.73 and 0.04. Add a 5 to both, and then subtract this unit by 1, yeah? So it'd be 2.725, 0.035. So that's bounds done. Now, to work out the upper value of Q, we need to ask ourselves, how do we maximize T over W? Well, now here's a little rule of thumb. When you're dividing or subtracting terms, the way to obtain the greatest value is to find the greatest gap between T and W. In other words, to get the maximum value of Q, so the max of Q, we need to maximize T and get the biggest value of T and divide it by the smallest possible value W. Why? Because this means that the ratio between them, the gap is really big. So you're going to get the biggest value. So the maximum value of T is this value, and the minimum value of W is here. So it'll be 2.735 over 0.035. Now if you put this in a calculator, hopefully you're going to get 78. And I believe that's it. So here is the graph of y equals sine x for x between 0 and 360. Okay, so here's your graph here. On the grid above, sketch the graph of y equals sine x plus 90. Okay, for 0 to 360. Alright, so what is this telling us? And this is very specific because they even tell us where you should sketch it between. This x plus 90 means that this entire graph has shifted by 90 degrees. Now, the question is it left or right? The trick to remember, if you remember this general form, fx plus a, when you write like this, you always shift to the opposite sign. So if it said plus a, it's going to shift to the left by minus a, yeah? That's what it means. This is kind of like when you're solving quadratics. If you put in a bracket, your answer is always opposite. So if it said x plus 90, shift to the graph by minus 90 degrees. Moving this graph 90 degrees to the left, we look at each point. This point goes here now to minus 90. 90 goes to 1. So actually, I'm going to just change the color of the pen. 180 here goes here now. 270, which is over here, goes here. 360, move here. Okay, and now we can just kind of predict it. So I just literally mess this up. So we've got this. So it looks something like that. Okay, so just carefully sketch along. And you can kind of guess what the next one is going to, of course, shoot up to here. Now, for this kind of question, it says sketch between 0 to 360. So in other words, we can't sketch anything less than. Because if you do, you might get penalized. I don't know. But my tip is stick to the range they want, which is from 0 to here. Okay. Let's move on to the next one. Okay, in the range between 0 and 360 for x, the graph of y equals sine x over 2 plus 3 has a maximum point A. Okay, just let's understand this maximum for a second, yeah? A maximum means the highest point on the curve, like here. So the maximum of sine x would have been when x is 90 and y is 1. That's an example. They want us to find the maximum of this point here, of this curve. Now the trick is, when you write like this, it can be done super easily. This plus 3 means that the y curve has gone up by 3. So now instead of it being at 1, it's going to go up by 3 points higher. So the maximum will now be at something 4. Okay, so that's a y coordinate for a second, yeah? As for the x coordinate, it gives us a hint. So remember how for sine x plus 90, we do the reverse. Here you do the reverse as well. If you divide them by 2 for inside the bracket, it's like you multiply x coordinates by 2 instead. So all the x values are now multiplied by 2. So that means if the original maximum point was 90, if you double this, you're going to get 180. So it's going to be 180 degrees. And that's it. I mean, visually, if you know what it looks like visually, let's just pretend this is 4 for a second, yeah? This means that all the x values have been doubled. So instead of hitting at 90, it's going to now hit at 180. Instead of hitting the x-axis at 180, it's going to hit at 360. And so on. So you can kind of see it's like a massive change. But yeah, so the answer you want is 180 and 4. Okay, number 19, guys. So it tells us that we got a quadrilateral here, and they want us to find the area of this entire shape. Now, conveniently, they literally cut a line across from D to B, meaning we got 2 triangles. So essentially, we need to find the area of both these triangles. Now, to do that, we need to use this formula. The area of the triangle, and this is also given from the booklet, is half AB sine C. So what this means visually is that if you had a normal triangle like that, you have the length AB and you got an angle between it C, we can work out the area of the triangle. So what we really want is we want an angle between 2 lengths. Now you can do it in literally many different ways, but we're going to try and find the shortest way, yeah? I think the best way to do is firstly work out this length DB to begin with, yeah? So let's call this X. If we can work out this length, we can work out this angle here, which is quite straightforward since we've got these 2 angles already. And if you have this length already, we have another length here and an angle between. So then that's it. We just work out X and we're done. Now to do this one and using the top triangle, we can use something known as the sine rule. Okay, so I'm going to go ahead and re-sketch this for a second, yeah? Just to make it easy on eyes. So you got 97 here, and you got 58 here. You got a length opposite 97, and you got another length opposite 58, 9.3. Okay, so the way the sine rule works is that if you have a length opposite an angle, you can apply it. And the sine rule tells us that if it's that the formula is something like A over sine of the angle A equals B over sine B. And we just literally substitute everything in. So the first little a is going to be x. It will be x over the sine of 97 equals length b, let's say 9.3 over its opposite, sine 58. And now all you do is just rearrange the formula and make x the subject. So to do that, we need to clear the fraction. We need to times sine 97 across. So x is going to equal 9.3 over sine 58 times sine 97. And now just put on your calculator, guys, yeah? You should get about 10.8846 ... I wouldn't round the answers yet, yeah? We're going to round it on the very last step. So now we found the value x here, so let's update this. So this is now about, what did I say it was? 10.88, yeah? Let's just make it 2 decimal places. So we can now work out this angle here, which is quite straightforward. So we've got all angles add up to make 180, so we've got 97 plus 58. That gives us 155. Minus it from 180, you should be left with 25 degrees here. Now we can finally apply this area of a triangle formula to the first triangle, yeah? So we can say that the area of this first triangle, let's call it A1, the first triangle, is going to be half times its 2 lengths, so 9.3 and 10.88. 9.3, 10.88 times sine 25. And then putting this in your calculator, you're going to get a total area of 21.38 centimeters squared. So that's just the first area, A1, yeah? And now we repeat the same thing, yeah? So let me change the colors. We got an angle between 2 lengths. So you got 11.2 and again 10.88 and this angle here. So the same formula applies. So the second area is going to be half times a, which is, let's say, 10.88, and then b, and then times sine c, 44.5589. And that's it. And now, to work out the total area, just add up these two numbers, yeah? And if you round it up to, what is it, 3 significant figures, you should get a total area of 65.9. 65.9. Yep, and that's it. I hope this is right. Write this quadratic into the complete square format. Okay, so a nice, beautiful way to do this here, and we're also going to review complete square here. So the trick is to firstly literally factor out the 3 first, because that's going to make a problem here. Yeah? So taking out 3 and just do a big square bracket, we're going to have x squared divided by 3, get minus 4x. Because 7 is not divisible by 3, if you divide it by 3, you just get 7 over 3, yeah? So leave it in that form. Now we're going to complete the square of this inside bit. So I'm going to change the color pen for a second. So again, big square bracket. To complete the square, underline the first 2 terms and then wrap it and then half the second term, so you can get x minus 2 all squared. Copy the third term, plus 7 over 3, and then minus it by the value you just factorized square, so 2 squared. And that's it. Now, yeah, we're actually done here. So now all you want to do is literally, to get into this correct form, the a times the bracket, it'll be 3 times the bracket, which would be, again, 3 times the bracket, literally. And now for the plus c term, you notice there's no bracket around it. So it's basically 3 times these two. So in your calculator, put 7 over 3 minus 2 squared, and then multiply that against 3. And when you do that, you're going to get exactly minus 5. And that's it. You've literally completed the square. Okay, part B. So the line of L is the line of symmetry of the curve with equation from part A. Okay, so this is a quadratic from part A. Using your answer to part A, in other words, this equation here instead of that, or otherwise, write down an equation of L. Okay, before we even figure out what this line of symmetry is, let's go ahead and sketch this curve, because that's going to help us solve this question easily, yeah? So here's our x-axis and our y-axis. Now, 2 things you need to know from completing square equations. One is the turning point. The points we just found here, these key values here, 2 and 5, are actually the turning point of a curve. Now, one thing we need to know is that this is a quadratic equation, so it's going to be a positive U shape, yeah? So because it's a positive coefficient, it'll be U shape. Now, this turning point means it's going to be the lowest point on this curve, which is going to be a y coordinate of minus 5 and x coordinate of plus 2, by the way. It's always opposite here. So the turning point is going to be positive 2 and what you see, negative 5. And let's just say 2 is here and minus 5 is here, yeah? So it's going to be somewhere around here. So our shape looks a bit like that. Now, if you want to, because it's a quadratic equation, it's going to have a perfect symmetry across. And this also means is that the line of symmetry can only occur over here through the center. And that's it. So this means that the line of symmetry cuts through 2, so the equation is x equals 2. And that is what they want. The curve C with equation y equals 10x minus 3 times x plus 1, so quadratic factorized, and the line with this equation intersects at the points A and B. Okay, so just wherever this curve is, let's just say it's quadratic probably, and you got a line here, and this is A and B, yeah? Find the coordinates of the midpoint of AB, in other words, this coordinate M, yeah, the midpoint. Now, before we get to the midpoint, when you intersect a curve with a line, this means you solve them simultaneously. Like literally, think simultaneous equations with intersection. Now, when you do that, you're going to end up finding a pair of x and y coordinates, one being A, one being B. And to get the midpoint, well, we can get to that next. I'm guessing this is 6 marks or something. Whew, yeah, 6 marks. So let's go ahead and try and solve this problem, yeah? So first things first, to do this easily, let's go ahead and make y the subject here, yeah? So we're going to have y equals 6x. Now we're going to go ahead and expand this fully, yeah? And simplify this equation. So we're going to get y equals, and then expand this double bracket. We use a FOIL method. It'll be 10x times x, 10x times 1, minus 3 times x, and minus 3 times 1. Doing so, you're going to get 10x squared plus 10x minus 3x minus 3. Okay, and by the way, this all equals to y, yeah? So all of this also equals to 6x, yeah? So this equals 6x too. And now all you want to do is go ahead and make all of this equal to 0, yeah? So move everything to the left hand side. So we're going to have 10x squared collecting like terms, 10x, take away 3x is 7x, minus 6x across, you can get plus 1x. You're left with minus 3 and it's now set to 0. So okay, so we're almost done. Now what you want to do here, let's have a look. You now want to factorize this equation. So this is going to be the main part. To factorize it, just use the quadratic formula, which is x equals minus b plus minus square root of b squared minus 4ac all over 2a, where a equals 10, the first value, b equals 1 for 1x, and c equals minus 3. So when you substitute everything back in, and when you use the plus button in your calculator, you should get a first result of x equals half. And then when you plug everything back in and use the negative part of the plus minus bit, you're going to get minus 3 over 5, yeah? So that's your x coordinates. Now this is easy. Since you know what y equals, since y equals 6x, you can say therefore, let's use it right here, y equals 6x. Therefore, when x equals half, you plug in half here. So 6 times half is 3. So we can get when x is a half, y is 3. So let's make coordinates here. For the second bit, when x equals minus 3 over 5, if you times against 6, so you're going to get, let me write it down, you're going to get minus 18 over 5. If you prefer in decimal form, which you can, it'll be minus 0.6 and minus 3.6. Okay. And yeah, this will be 0.5 and 3. Now, so we found two pairs of coordinates, so it doesn't matter where is where, by the way, yeah? What is what? They want us to find the coordinates of the midpoint of AB, so the coordinate M. So to get the coordinates of any midpoint, the trick is that you have to add the x coordinates, so 0.5 plus minus 0.6. So let me do the other way around. Minus 0.6 plus 0.5, and then you half it. This gives you the x coordinate. To get the y coordinates, you do the same. So add up minus 3.6 and 3. So minus 3.6 plus 3, half it, and you get the y coordinates. And when you do that, you're going to get something like minus 0.05 for x and minus 0.3 for y. And that's it, guys. That is your midpoint. So okay, so OPQ is a sector of center O, and OAB is a small sector. So in other words, we've got a massive sector here, and they give us a small sector here. Okay, so a sector within a sector. Now A is the point on OP, so this point A, such that O to A and A to P is in the ratio of 3 parts, 2 parts. In other words, if this had like, I don't know, a radius of, let's say this was 3x, this would have to be 2x's length. Okay, and B is the same. So again, 3x and 2x. So what this tells us so far that this is basically a radius of the same amount. So this is definitely a sector. Now angle POQ is 45. The area of the shaded region is 81 over 2 pi. So let's just highlight that, yeah. Work out the perimeter of the shaded region. Oof, that's an interesting one. Okay, to work out the perimeter, let's try this out, yeah. Before we even do that, let's try and figure out what the true radius is, so we can actually work out the more finer details, yeah. So what we could do so far is pretty much write down every possible formula so far, yeah. So we can say that the area, since we're dealing with area, the area of a sector is always a fraction of the 360 times the area of a circle, pi r squared. Let's call this little one area 1 and call this entire shape then the massive sector with radius of 5x and area 2, yeah. So to work out area 1, it's going to literally be 45 over 360. I'm just going to simplify that quickly, yeah. That's going to be 1 over 8 times pi, and the radius is 3x squared, so 3x squared, yeah. Now for area 2, it's the same thing. The massive shape is going to be 1 over 8 times pi. The radius is 5x squared, and we know that the total area is gonna be firstly 81 over 2 pi plus that little area A1. And yeah, so far so good. So now you can kind of probably see that we're going to deal with some sort of simultaneous equation again, yeah. So what we could do, since we've got A1 here, you can literally substitute this equation into there. Let's try it out for a second, yeah. We're going to now have 1 over 8 pi expand 5x squared, yeah. It's going to be 25x squared equals 81 over 2 pi plus, and then A1 the same thing, 1 over 8 3x squared. So 1 over 8 pi expand 3x squared, you get 9x squared. And now let's go ahead and see if we can simplify this, yeah. When you have pi in every single part of the term, if you divide by pi, they all cancel out. Also, you got 25, and then you got all these x's, yeah? So we got 1 over 8, 25x squared. Combine it, you get 25 over 8x squared equals 81 over 2. Plus, and then same thing here, you're going to have 9 over 8 x squared. So I think we could find the value of x so far. So to find x now, let's go ahead and make all the x terms on left. So subtract 9 over 8 x squared to the left hand side. 2x squared equals 81 over 2. And then to find x, divide 2 across. So you can get 81 over 4. Square root, you're going to get square root 81 over 4, you get 9 over 2, which is 4.5. So yeah, so conveniently x is 4.5. So now we can actually update this properly. So let's just redraw our shape here. So if x is 4.5 and the whole thing is 5x, you can do 4.5 times 5. This will give us a total length of 22.5 centimeters. Yeah, so that is the true radius of the whole sector. And here's 45 degrees. And now this is almost done. Yeah, to find the length of an arc is this bit. The formula is like this. The length of the arc is actually the same as the area formula, so it'll be 45 over 360 times the circumference of the circle, which is 2 pi r. And that's it. This will give us this L bit. And when you put all of this in the calculator with the radius being 22.5, you're going to get exactly a length of 45 over 8 pi. That's the length of the arc here. Okay, so we now found the big arc here, L1. And that's basically this part here again, yeah? We now need to find this small arc, L2. Now to obtain L2, we just do the same thing. The only difference is, instead of the radius being 5x, it's just going to be a small radius of 3x. And remember, x was 4.5, yeah? So just plug into this original formula here, with r being, the radius being 3x. And now you're going to get an actual total length of 27 over 8 pi. That's when you plug in everything here, yeah? So now we got everything. We literally just sum them up. So the total perimeter is going to be L1 plus this 2x length plus this other 2x plus L2. So let me just write here, yeah? So perimeter is going to be the first arc plus the second arc plus 2x and 2x, which is 4x. So that's it. If you plug all this in the calculation, then end up with 9 pi plus 18. And that's it. This is your final answer. Okay, the last question. Let's do it. So the 10th term of an arithmetic series S is 66. And the sum of the first 20 terms of S is 1290. Find the 5th term. Okay, so to do this nice and easy, let's write down all the formulas we know about arithmetic series. First, we have the nth term, which I'm going to call it un. It's always given by a plus n minus 1 times d. And then we've got the sum of the first n terms, which by the way is given in the front of the book, is n over 2 times 2a plus, the same thing, n minus 1 d. So that's just a general formula for the nth term, like basically a position, and the sum of the first n terms. Now it tells us from information that the 10th term is 66. So if we rewrite the first formula, we can say that a plus n minus 1d. So a plus, since we know it's a 10th term, n is 10, so it'll be 10 minus 1, so 9d, must give us a result of 66. And we know that the sum of the first 20 terms, so s20, so we're going to have 20 over 2, which is 10 times 2 times a. And here, since n is 20, it will be 20 minus 1d, so it will be 19d. And it must equal 1290. Okay, and just to simplify further, if you divide 10 across, you'll be left with 2a plus 19d equals 129. Alright, so what do we do next from here? So now, if you look at both these equations for a second, yeah? Before we even solve the question, let's try and figure out what the value of a and the value of d is. And by the way, guys, I didn't say this earlier, but a is the first term and d is a common difference, yeah? So to solve this simultaneously, various methods, but what I'm personally recommend is to just go ahead and double this equation by 2, yeah? And subtract it from this equation here. And when you do that, you're going to have, at least when you double it, you're going to get 2a plus 18d equals double 66, 132, yeah? And that's it. So now we just solve this simultaneously. Subtracting the equation, you'll be left with d equals -3, which is perfect. If you know what D is, you can plug into the first equation and get A. So we're going to now have A plus 9 times minus 3, which is minus 27, equals 66. Adding 27 across, so 66 plus 27, you get 93. Okay, so it looks like we've done it. Now finally, they want us to find a fifth term of S. So the fifth term, let's call it U5. And using the general form, which is over here. A, since we know what A is 93. N is going to be 5, so it'll be 5 minus 1, which is 4, times D, which is minus 3. And then putting this in your calculator, you're going to get 81 for the fifth term. And that's it, guys. Hope this video helped, and let me know if you've got any questions or any problems, or if you want me to break down anything further. But otherwise, I hope you guys had a nice day and enjoy the walkthrough, and I'll see you guys next time. Ciao.